Good morning or good afternoon, ladies and gentlemen. Thank you for joining this session. So over the next 35 or 40 minutes, we're going to talk about industrial control systems, cybersecurity, or securing operational technology in industrial control systems, and what Gigamon can do to help enterprises and organizations achieve these objectives. So just a couple of minutes to introduce myself. My name is Vladimir Yordanov, and I head the System Solution Engineering team in Asia Pacific. Prior to that, I was with companies. I was a cybersecurity officer for Huawei, and also I held leadership positions with companies such as F5 Networks, Imperva, PricewaterhouseCoopers, Samsung, and overall, I have been in cybersecurity for 20 years, more or less. One interesting fact about me is that I spent a number of years working as a threat researcher and compromise recovery investigator, help organizations deal with situations when they have been compromised, cybersecurity compromisations, or they have suspected that they have been compromised. So I want this thing to be an interactive session. So at any point, if you have any questions, please feel free to ask them. So what we're going to talk about it today is that we're going to spend some time introducing ICS and OT. We're going to cover the security threats and risk. I'm going to spend a little bit talking about standards, regulations, and frameworks, how the technology differs between the two technologies, OT and IT, and the last 5 minutes or 10 minutes, we're going to talk about how Gigamon can help in that area. So let's start with a brief introduction of operational technology in industrial control systems. So when you look into the historical aspects, then industrial control systems are not a new thing. And even when you look into the first industrial, second, or third industrial revolutions, at any point, there was some attempt to automate and to introduce some sort of control within the process. And security and safety has been part of it throughout the entire lifespan when the industrial revolution started. Where we are today, we could say that we're into industry number 4.0, where we have the systems, not just automated systems, but also the systems connected, they interact with each other, and they're capable of making autonomous decisions. And we have several technologies that enable that. The latest one, the talk of the town, has been 5G and how 5G is going to impact the industrial systems. But 5G, when you look at it, is just a new and faster and better way for systems to communicate. Artificial intelligence, the advancement in semiconductors, all those technologies combined together, they lead us to this very moment. When you look into cybersecurity aspect to it, so information technology, one of the first part of the CIA triangle is confidentiality. A lot of efforts, a lot of time is spent in IT to protect the confidentiality of the systems. There are a number of legislations that have been adopted. Then integrity and availability. In OT, this is different. Availability is number one priority. And reason being is that industrial systems that have to be available all the time because they support automated processes. And if those processes stop working, loss of revenue is one part of it, but also loss of life. Environmental factors, environment could be affected, and many other aspects that affect the human life directly. Then we talk about integrity. Integrity in a sense that the system operates with data as it should be, that nobody has tampered with it. And then confidentiality comes third. And that leads to different performance, availability, operational requirements, and of course, risk management goals between OT and IT are different. So when you look into the way IT and OT systems are designed, operational technology followed the so-called Purdue Model. That model was designed a while ago, by the way. But one thing, what I would like to point, and today everybody's talking about convergence, that OT and IT are converging together, etc., etc. But when you look at this model, convergence, or the point where operational technology, ICS, OT, and enterprise IT connecting, it is part of that model that I think that, if I recall correctly, was designed in the mid 90s. So even when the initial architecture was built in, was conceived, it was already planned that at one point OT and IT will converge, and they have to interact with each other. Of course, there are some changes that are brought by today's environment. So several challenges that are specific to industrial control systems, OT. The attack surface is complex and very large. The air gaps, traditionally, the solution was air gaps, complete air gap between the two systems, but that's no longer help. Industrial protocols not easy to secure. Legacy systems, a big part of it. A lot of the industrial control systems implement legacy systems. They run on Windows NT. The PLC controllers could be very old, and the software as well have been written many years ago with limited and no support. And probably one of the most, the biggest challenge is lack of visibility and control. When you take, for example, oil refinery or utility plant, there could be thousands and thousands of sensors, and this is just for one installation. Imagine when you have multiple number of installations and you have to control thousands of devices that probably you don't know where they are, or it's difficult to find them. So visibility has been ranked as one of the number one security factors for industrial control systems. So let's spend in the next couple of minutes talking about the threats and risk into industrial control systems operational technology. So first couple of myths, and I really like to talk about those things. Starting with the first myth is that we don't connect to the internet. Well, that's really not true anymore. And one audit done about 15 years ago, and that is actually 14, 15 years ago. Imagine what the situation is now. Showed that more than almost 90% of the control systems are connected to the business network, and through the business network, they can be connected, they can be infected, and they can be attacked. And since most of the IT systems are connected to the internet, by inheritance, OT also could be connected to the internet. Also, that control systems are behind the firewall, not really. There's, yes, there are industrial firewalls, absolutely, but they're not really widely implemented, and they're implemented into parts of the network and most of the control systems, they're not protected by firewalls. The other myth is that the hackers don't understand control systems. That is not really true. I have worked with security professionals that on both sides. I had actually I ended up investigating several control systems that have been infected. First, hackers do understand industrial control systems. Second, it's not really that difficult to hack them. And I have seen demonstrations of how fast or how easy is to infiltrate industrial control systems via wireless connected cameras. So from the cameras, the hacker managed to the Wi-Fi cameras, they managed to infiltrate the entire systems. Of course, everybody's a target today. Modern safety systems are not really that well designed to protect against what the cyber criminals can bring against you. So what are the attackers' objectives? And when you're a bad guy, when a malicious actor, and you're planning to attack IT or OT, there are different objectives. So attacking IT systems is generally data theft, revenue, stealing money direct from banks or from other financial institutions, damaging of reputations, etc., etc. Versus the objectives to attack of ICS systems is damage of property, damage of or loss of life. If you remember, one of the attacks that was done, it was called, by the way, there was an attack developed against the Iranian nuclear centrifugal system that would make them spin out of control, leading to damaging of the centrifuge itself. And potentially leaking radiations throughout the facility. So ICS attacks are very dangerous, as I mentioned earlier. They could lead to loss of property and endangering human life, even loss of human life, and harming the environment. So this is the standard kill chain in IT developed by Lockheed Martin. Security professionals are familiar with it. It's been around for quite some time. But when you look at ICS, in ICS, there are two distinct stages. So the first one is the preparation, and start the planning, preparation, attempt. I'm not going to go through all of them. And then the second stage is development and execution. The reason being so, and usually in terms of a lifetime, those attacks may happen over a very long time. One thing what we have to consider is that we're talking about industrial control systems being attacked over the internet, but that may not be longer. The internet is not the only inception point. It could be a direct physical attack, the direct physical access to the systems. The delivery method could be, there could be many delivery methods. Could be disgruntled employee or internet. So the fact that, and this goes to my first, one of the first points that I made, that even if you have an air gap between your OT and IT, that is not really going to protect you that much, because the delivery mechanisms today vary, and there are many points and many access methods and many ways for attack to be delivered. The other point that we also have to consider, sometimes those attacks could take a long time. Maybe like 5 or 6 years ago, when you have been attacked, you knew it. The attacks were noisy. They generated a lot of activities. Was very easy to be detected. Today, the situation is a little bit different. The attackers take their time, especially when you move lateral or vertical movements, making sure that they don't trip any alarms. So here is some of the attacks that have happened. The attacks are real, and most of you have heard of those attacks, have seen them in the news. But what I really want to show you, this video, I hope that you could see the video. So if you recall, that was the attack that happened 5 years ago on the Iranian or the Ukrainian grid. So I'm going to mute that the video, because unless you speak Russian, you won't be able to understand it. But this is what you see. This is the actual attack happening, and it has been recorded by one of the engineers. And the attackers, what they did here is that what really saved them in that particular situation is that that station was not connected to the grid. So although they have trying to flip switches, they couldn't really do it. But in other stations, actually, they managed. So overall, the attackers did manage to shut down the Ukrainian grid. But this is what the attack looks like. And nobody's touching the mouse. The cursor is moving and trying to click on the commands. And trying to open the relays, shut down the stages, shut down the relays. In the meantime, the guys are wondering what's really happening. Maybe we should call the IT guys, so the IT guys are doing it. Yeah, so that's what happened. Attacks could happen. Just imagine the consequences if that station, if that workstation was connected to the actual grid. Then in real time they would have been able to shut down or to turn off those relays, which eventually they did, because the attack did manage to what they did is that they left over 225,000 people in the dark. All right, so it's real, it's here. Okay, so the favorite topic for everyone, standards. And when I was preparing that presentation, I was wondering, shall we talk about it or shall we not? And I gradually, when I started working in cybersecurity, and initially start being brought to standards and compliance, I did not like them, but I gradually grew up to respect and like the standards and compliance, because they really give you an order, they give you a viable framework to work with. And I really want to spend some time to explain the definitions, because they're different and they have been misused in cybersecurity, and especially when it comes to industrial control systems, OT. So the first one is we have legislations or law. And this is by law, you have to do it. You have no choice. Could be the law could be so one of the laws that affect that is recently has been adopted in North America is there's a law that, for example, forbid the federal government installations to use equipment from certain countries or certain manufacturers. Industry regulators, they also could use the legislation framework to demand certain standards that needs to be followed, or framework. So that is for example, you could have the central bank requiring everybody must follow PCI DSS standards, right? So this is the law. You have to follow, no choice. Although most of the cybersecurity laws, they give a lot of leeway in terms of how cybersecurity standards should be implemented. Then we talk about the standards. and those generally published materials that everybody has agreed. So ISO, NIST, NIST, etc. Then you have a framework, and framework basically is its approach, something that everybody's agreed that needs to be done. But there's no really, while for the standard is a very well-defined method, and you have ABCD that needs to follow. Security framework, then it's a little bit more, it's more loose in terms of definitions, and quite often, depending on who you're talking, you may actually get different definitions for different frameworks, especially when you talk to security vendors. And of course, the compliance is the practice that you go to adherence and conformance to standards. Not compliance means that you have fulfilled some standards, not really a framework. You can't really be compliant to a framework. This is what usually organizations are required to do. ISO 9000, ISO 28001, those are the standards that need, and there's some specific standards for the ICS that needs to be followed, and I'm going to cover some of them. So some of them so original standards, for example, NERSIP USA in USA, or EP, CIP in Europe. Then we have the ISA and IEC 62433. We're gonna see it later. You have the NIST 800-82, and my favorite one, 800-53. So the first one is Guide to Industrial Control System Security, and the second one is the Overall Security Controls for Federal Systems. A lot of the controls that are in 800-82 come from 800-53, and 800-53, that is probably one of the most comprehensive collections of security controls. So this is what ICSs looks like. It covers several systems. It covers the general part. Covers the. It provides a very flexible framework to address current and future security controls. Has been developed quite a while ago, but it's still very relevant. And organizations are required. A lot of organizations are required to follow it. NIST is another one that has been developed by North American Institute for Standards and Technologies, and this is the 800-53 that pretty much all of the security professionals, IT and security professionals across the world are familiar with it. So keep those things in mind. I think that later on we'll be given an access to the slides, and if you have to use a starting point, those 4 points, those 4 standards would give you a very good starting point. And I always recommend organizations to use some set of standards when they design the security systems, whether it is required by law or not, because it gives you fundamentals on which to start building your systems. And the other thing, what you need to remember when you work with standards and when you work towards compliance to specific standards and frameworks, that they give you standards. Compliance to standards would guarantee you that you have a certain security controls in place. It would not guarantee you that you have those controls are effective. So that's what that is actually a separate set of actions that needs to be taken to ensure that the security controls that you have implemented are working, that they do what they're supposed to be doing. So this is the critical infrastructure, what is defined by United States. So a number of communications, chemical, healthcare, all those industry has been defined as a critical infrastructure that heavily depend on industrial control systems that need to be protected. And then this is the Europe one, United Kingdom. Okay, so let's spend a couple of minutes to talk about how industrial control systems and IT are different from a cybersecurity point of view. So we already covered that. I mentioned briefly is that IT attacks, so information, we kind of like wait for patches, and confidentiality is number one. In terms of OT, is attack on humans, infrastructure. If you wait for the patches, actually that could be disastrous, because by the time you patch the systems, will be the consequences are very severe. And as we're moving forward, availability is really important. In integrity as well. It's not just the system have to be available, that is very important, but also the system has to operate as it is intended. The other part, there some other systems, it's a little bit difficult to read it, and I hope that that actually you can read it well on this on your screens. There's quite a few. That particular difference was developed by SANS, and sorry, that was developed by the USA government. But several one that I need to bring to your attention. One of them is the way the systems are developed, right? Secure system development. While IT, there's a concerted effort in terms of making sure that DevSecOps, etc., are followed. Not really in OT. One may think that is the case, but in reality, it's not. Bear in mind that a lot of the control systems, industrial control systems, have been developed many years ago, when like DevSecOps even did not exist as a concept. Another asset classifications is another difference. So in IT, we know pretty much what we have. It's very easy to do it. There's not just as a part of the purchasing process, but also it's very easy to scan your network and find out what it is. Not so much in industrial control systems. And I'll give an example. We work with one of our partners, and they were it's a visibility ICS analytical solution that was implemented for a major chemical plant, and that chemical plant they were undergoing updating all of their logical controls to the next generation software. So they contracted some vendor to come and do it for them, and they did everything. And when later, and a couple of months later, when our partner solutions was turned on, they discovered that initially they upgraded only about 40%, so about 60% of the systems, and they had about 40% that were not upgraded because they didn't know that they have them on the systems. And you cannot protect what you cannot see. So classifications and visibility is really important in industrial control system. Patch management is also very difficult, and also testing. Once you move into ICS OT, things that are easy to do in IT technologies are not so easy, or you have big challenges to do them in industrial control environment. So when you look at from Purdue model and NIST model, they're also different from architecture point of view. And there's some key points that needs to be considered. You have to keep your entry points to minimum, right? Then you have to split your zones into smaller, more focused environments where the security controls can be applied consistently. Also, the systems containing the ICS data need to be protected by firewalls and need to be controlled by policies. Zero trust comes to mind, and I know that zero trust has been in the talk of many cybersecurity professionals today. But when it comes to industrial control systems, this is where zero trust networking can really help to achieve very solid security posture. You have to implement the visibility and monitoring solutions, and you need to isolate the database and monitoring systems. When it comes to intrusion detection prevention sensors, you have to make sure that they cover the entire infrastructure, not just partially, but the entire infrastructure. And this comes, this actually links directly to the previous example that I gave you. With the customer that they thought that they have captured everything, but about 40% of the controllers, they didn't know that they have them. When you're in situations like this, basically you have about 40% for ICS unprotected. Okay, so any questions at this point before I move to the last part of my presentation? Okay, so Gigamon and what Gigamon can do in ICS. All right, so and how Gigamon, what role Gigamon plays into achieving security objectives. Okay, so let's recap on the challenges. One of the challenges is the safety, availability, integrity, confidentiality. So that is number one objective, it's not easy to achieve. And when you, as I mentioned earlier, if you the focus is on safety and availability, followed by integrity and then confidentiality, and any compromisations in that area can have severe consequences. Fail open systems during the attacks, during the system must be available. And reason being is that you have to be able not just to isolate the control, but even when we have been attacked, you have to be able to continue with the processes so that the attack does not damage or does not bring down your manufacturing process. Bear in mind that some manufacturing processes 24/7, they cannot be shut down abruptly. And if you do that, that actually could have not just the financial losses could be in a range of hundreds of millions or even billions of dollars. You have to consider the legacy systems. A lot of the systems into the industrial control systems has been implemented a while ago. Vendors may not be available anymore. They have been gone out of business or acquired by somebody else. All the technology, a lot of times in Gigamon we'll work with customers in OT systems. 110 meg, 10 meg, 100 meg. That is the standards. In the switches, they don't really have span ports or mirroring ports, right? Also, ICS is built on proprietary hardware and software that is difficult to support. A lot of tools. Everyone who comes into a touch with those systems, or every head of IT, bring its own bring its own tools, its own legacy, or its own vendor. And at the end of the day, once you look throughout the entire life cycle of the systems, you have so many tools, and the challenge is that there's no tool that have a complete visibility. And last but not least, control engineers and operators, they're not really very skilled in cybersecurity. Right. Another thing is that, and I think that this is a good slide that indicates the symmetry between IC, industrial control system operational technology, and IT. In IT, for example, you have the security that you have, like the antivirus, firewalls, IPS, IDS, and then afterwards you have your control systems. And then the exposure systems, the exposure window is much, much smaller than what you would have in OT systems. And traditionally, monitoring of security events in operational technology environment, in industrial frameworks, it is very difficult. The challenges, that has been a challenge that organizations have been trying to solve for quite some time. And right now, for the last, I said probably 1 or 2 years, we see progress that has been made because of the availability of the development in technology. The cost is lower, and it's much easier to implement a good visibility without really shutting down expensive manufacturing process. And also that actually could meet the requirements of distributed geographic environment. When you look into, of course, utilities is one area that, or chemical refineries, they could have multiple sites. But when you look at mining, and mining, for example, is a huge consumer of technologies of both IT and OT, and they have multiple sites across the entire world that needs to converge to a central point for operationals, financials, management purposes. And this is one other area which need the distributed geographical environment is also needs to be considered when we secure ICS OT systems. Right. So, which brings to the point of the importance of visibility, industrial control systems, operational technology. So, visibility results in security, in better security. You cannot protect what you cannot see. And you need, there are many points. I'm not going to read through all of the points, but first and foremost, when you secure your industrial control system operational environment, you need to get access, you need to get visibility to the data. You need to be able to have a complete north, south, and east, west visibility within the infrastructure, so that you can detect attacks, you can protect them, you can defend against the attacks, and you can triage, you can have a meaningful information that would enable you when you have to deal with attacks. The resilience also it is very important, because resilience, this is the capability or the ability of organizations to deal with attacks, detect the attack, isolate it, then afterwards minimize the impact, evict the attacker, and then recover from the attacks. And the only way to do that is that when you have visibility into the industrial control systems. Right. The other point is improved total cost of ownership. When you have an integrated platform that it can provide a complete visibility into your OT traffic, You minimize the tools, you minimize the traffic, you take advantage of the scale, so that at the end of the day, as your infrastructure grow, as you continue to rely on the monitoring of your industrial process, you don't drain the bank. And also, as the attacks continue to evolve, and you need to defend against different types of attacks, you can add or remove tools without really having a major upgrades or changes within your infrastructure. So when you look into the Purdue model and how Gigamon fits into it, and we play a role on both on the IT area and the OT area of the model. I can give an example without really mentioning customers, but we had a major industrial installations that they had about 2,000 collection points. The 2,200 collection points. That and those sites, industrial sites, with heavy machinery that was moving goods and managing processes, and any changes or damages to the operational state of this machinery, on this equipment, would have result not just in economic damages, but also literally in loss of human life. And because it was a distributed site with over multiple geographical locations, and even each site was fairly large, so they have to rely a lot on wireless communication, although secure, but still was wireless communications that with a little bit of resistance could have been compromised. And Gigamon worked with them very closely to help to ensure that all of the data from the sensors is collected on the operational sites, on the ICS operational sites, and then it is sent to the IT site securely, and then from the IT site is sent further to the tools and security system for processing, monitoring, defense purposes, analytical purposes, processes, monitoring, the full nine yards. And we really help them to achieve this without interrupting the process. We also improved availability, because at the moment there was something was not going according to plan, or any of the site was having some issues, was becoming visible immediately, right? We also help them minimize the number of tools. Typically, before Gigamon, they had several different tools. After Gigamon was implemented, they actually narrowed it down to 3 tools, one for security, the security infrastructure, then they have the operational monitoring, and then afterwards they have the processes and analytical. And last, this is some of the vendors. This is some of the solution providers that we work with: Clarity, Nozomi, SCADA, CyberSecurity. Those are all very good analytical and monitoring systems for industrial control systems that I think that if you don't have them, you should consider them to work with them, because I've worked with Gigamon and in other capacities with those companies, and they have a very good solution. And here are some solutions that you could look at it. There is actually, we have developed solutions with Nozomi and SCADA that are available on our website. And in conclusion, wrapping it up, The convergence between IC, industrial control system, OT, and information technology is here. It's already happened. It was predicted 15, 20 years ago, but it's happening. And the security breaches of OT are very dangerous. They not just impact infrastructure and lead to monetary losses, but they do endanger human lives and can have a devastating impact on the environment. It is a very complex infrastructure with a very long life cycle. While the IT may have a life cycles of maybe 3 to 5 years, OT life cycles is easily 10, 15 years. Also, when you talk about compliance, you should not limit only to ISO or NIST, but also should consider your best practices, not just internal, but external. And I work, in my experiences, I work with a lot of refinery and oil industries. And that is one industry that I really have seen in Asia and Middle East, that I've seen them really driving and collaborating together to share best practices and making sure that they have implemented solutions that can really help them achieve solid defense and security posture against modern threats. Another thing, what I need to bring to everybody's attention is that small things help. Do not underestimate education, for example. About 75% of the cybersecurity incident could be eliminated by following a proper cyber IT hygiene. So Telnet versus SSH, SPAN versus STAP. Don't leave ports open. Making sure that if it doesn't have to be accessed, do not access it. And the last is that visibility is fundamental in resilience, detection, protection, and mitigation. You cannot protect yourself against what you cannot see. And the strongest, the punch that knocked you down is not the strongest one, but the one you cannot see it coming. So at that note, I want to thank you very much for your attention and hope that you find that session useful. And you will have access to the slides through the event website. Thank you very much.